Okay, for the lesson today, we are going to be looking at 1.3 compound interest future value. So by the end of this lesson, we should be able to compare the advantages and disadvantages of simple interest and compound interest, solve contextual problems that involve compound interest, and apply the rule of 72 to solve investment problems and explain the limitations of the rule. So for compound interest, the interest that is earned are paid on both the principal and the accumulated interest. So when we're talking about compound interest, how it works is, so for example, if I put in $5,000 at the beginning and it's compounded, say, monthly. So every month I'm going to do a new calculation based on the money I have. So say, okay, we start with that 5,000. First month we do our calculation, we gained an extra $100. So now what's sitting in the bank is $5,100. So the following month, when we do the calculation again, we're going to base it on that $5,100 that we have. And so say we do the calculation again, we gained an extra 120. So now we're at 5,220. And so when the following month, we're going to now do the calculation on that 5,220, and so on and so forth. So it's always based on what you earned before, whereas the simple interest, you always went back to that beginning amount you put in. So the really important thing we need to know for this is this compounding period thing, and it's the time over which interest is determined. And so there's different ways that we can do it. It can be annually, so we do the calculation once a year. Semi-annually, we do it twice a year. Quarterly, we do 4 times a year. Monthly, we do 12 times a year. Weekly is 52 times a year, and daily is 365 times a year. So the formula that we're going to do with this is A is equal to P times 1 plus I over N, all raised to N times T. And so yeah, for this, like if it's monthly, we're not going to actually do 12 different calculations. We're just going to use this one formula, and it will give us the end result. So A is our future value, and that's the investment at maturity. Our N is the number of interest calculations per year. So say it's quarterly, it's 4. And the T is the term in years. And the thing that I forgot to include in this is I is equal to our interest rate. Just note, this I and the I in the simple interest formula, 2 different things. We could, if we wanted to make them more similar, we could replace this with the R that we were using for the interest rate in the other formula. That means the same thing. All right. So in this section, we're going to learn to use the formula, but the thing that we're going to start doing is allowing the computer to do the calculations for us. So what we're going to do is we're going to go to this financialcalculators.com and use the investment calculator on there to do a lot of our calculations. So if I go to the financialcalculators.com, this is what will pop up. And I'm going to click on the top bar, this online calculators. Scroll down until I find this investment calculator. So, nope, didn't go far enough. Investment calculator. Click on that, and you'll have a calculator that pops up that looks like this. Most important thing to do is to make sure that everything on the right-hand side either says 0 or no. And then in a little bit, I'll show you how to use the left-hand side. And then the last thing that we're going to be doing is this rule of 72. So it's just a really quick way to estimate the time it would take an investment to double in value. And so to do this, and the reason why it's called the rule of 72 is you take 72 divided by the annual interest rate, and it's got to be as a percent, and that'll get you the number of years it takes to double your investment. Just a note, the rule of 72 works best with compounded monthly. Every other compounding period, it will be off by a bit. Okay, so we're going to do this example, and we're going to use the formula for the first way. And then the second way, I'm going to show you how to use this investment calculator, and hopefully our answers match. So to use the formula, same way as we were doing the simple interest formula, you write down your lettering. So for this one, we need an A, we need a P, we need an I, an N, and a T. So for our problem, we got 23,000 is invested, so that's the starting amount, so that's my principal. It's invested at 13.6%, so that's my interest rate. And just like the previous formula, plugging in your interest rate needs to be written as a decimal. So this one is 0.136. The N is our compounding time, and so we're compounded semi-annually. This semi-annually means twice, so our N is going to be 2, and then our T is 10 years. Just a note for future problems, how you tell the difference between a simple and a compound is that the simple will say simple, and the compound says compounded. And now I'm going to go to my formula. So A is equal to P times 1 plus I over N, and that's raised to N times T. I'll plug in what I'm given. So the 23,000. The 1 always stays 1. My interest rate is 0.136. The N is 2. And then I'm going to raise that to N, which is 2, times T, which is 10. And so now I just got to pull up my calculator, and I'm going to plug that in. So typically how I do this is I start with the fraction, add the 1, do the exponent, and then times it by the 23,000. So I'm going to do 0.136. I'm going to divide that by 2, plus 1, and I do hit equals in between each of these steps. So, and then I got to raise that. So your exponent button is either going to have this XY on your calculator, or some of you might have, kind of looks like a little hat button. That's an exponent button as well. So you're going to hit the exponent button, and we're going to raise that to 2 times 10. So in brackets, I'm going to do 2 times 10. So, and then I got to finish by timesing by 23,000. So I'm left with 85,733.96. So now what we're going to do is we are going to see if using the financial calculator online works out to be the same. So what I did here, down here, is just a snippet of what your calculator should look like when it goes in, just so you can have it in your notes. So bring up the financial calculator, and it is, okay, so our starting amount was the 23,000. This periodic investment amount is just going to be 0. That's only there if you're like putting in, say, like $100 per month or something like that. For all our current calculations, has nothing to do with what we're doing right now, so it's going to just be 0. We'll get to that kind of stuff later. The number of cash flows, so this is probably where people will make errors, is basically the number of times it's going to be compounded through the life of the loan. So what's happening is for this one, we are compounded semi-annually, so that's twice a year, but that's going to be for 10 years. So we're twice a year for 10 years, so that means it's going to be 20 times altogether. So basically, you take your N times your T, and then that's what goes into the number of cash flows. Okay, your annual rate of return, that is just the interest rate, so 13.6, and this time it gets entered as a percent. The calculator does the calculations for you. Our goal amount is our unknown. And now for today's date, typically what I do is I just, whatever month it is not important, but I just make sure it's the first of the month. Makes things easier. And now for the first cash flow, so we're semi-annually, twice a year, so that means the first cash flow will be 6 months later. So I'm going to change the date to 6 months later. So October would be 1, 2, 3, 4, 5, 6. So 6 months later is going to be March. So March 1st. And then our investment and our compounding, we're just going to switch that to that semi-annually that was in the problem. And then I hit calculate, and look at that. In the goal amount, we got 85,733 and 96 cents. Just a note, for the stuff down here, just ignore it. Because as you can see, it's off by a little bit because it's changing your interest rate for some reason. I haven't figured out that one yet. So just always go by what's popping up in this section here. And that ends our video for today.